which covers basic properties of real numbers. So we're going to learn all of this, which is in section 1 of the textbook. So properties of 1s and 0s. 1 and 0 is, they're special, so they have the following properties. For any real number x, x plus 0 equals x. So if x in this case is 2, 2 plus, okay, this is like the third time this has happened, I'm getting really annoyed. 2 plus 0 equals 2, okay? For any real number x, x times 1 equals x. Again, if 2 is x, 2 times 1 equals 2. No other real numbers besides 0 and 1 have these properties. So that's fun, I guess. This property, additive inverse property, states that any real number x, there's a unique number denoted by x, negative x, such that x plus negative x equals 0. So if x in this case is 6, that means negative x would be negative 6. So x plus negative 6. Oh, hello. Hello, can we work? Thank you. 6 plus 6 plus, don't you dare, plus negative 6 equals 0, okay? This checks out. This checks out. This works. This works. Multiplicative inverse property. This states that for any real number x different from 0, so x can't be 0 in this case, there is a unique number denoted by x to the power of negative 1, such that x times x to the power of negative 1 equals 1. So let's say x in this case is 2. X equals 2. If y'all remember anything about numbers being to the negative power, you know that it's going to, raise it to that power, but also put it as a fraction form. So in this case, 2 to the power of 1 is just 2, and it's going to be put in fraction. So 2 to the power of negative 1 is just 1/2. So you just do 2 times 1/2. And of course, switch to blue. So associative law of addition. This states that for all real numbers x, y, and z, x equals x plus y plus z. So let's pretend x equals 1, y equals 2, and z equals 3. Just for simplicity's sake. So x plus, hello, this is getting annoying. 1, 2, 3. 1 plus parentheses 2 plus 3 equals oh my god. If you can't tell, this is like my 4th or 5th time trying to do this, and it keeps messing up, and I just don't care anymore. 1, so this is 1, x is 1, y is 2, z is 3. 1 don't you dare. 1 plus 2 plus 3. 3. Hello. Equals. So basically, 1 plus 2 plus 3 equals 1 plus 2 plus 3. It's just both equal to 6. Try on the slide. This law states that all real numbers x plus y, x plus y, what the? Oh, for all real numbers x and y, x equals y plus x. So if x is 1 and y is 2, 1 plus 2 equals 3, and then 2 plus 1 also equals 3. So that checks out. That makes sense. Associative law of multiplication. For all real numbers x and y and z, x times y times z equals x times y times z. So again, let's make x1, y2, and z3. 1 times 1, 2, 3. 1 times 2 times 3 equals 1 times 2 times 3. Please, 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 brackets, do not mess me up. Thank you. Obviously, 2 times 3 equals 6 times 1 equals 6. 1 times 2 is 2 times 3 equals 6. So, of course, 6 equals 6. So this checks out. I'm going to go back to blue. Actually, let's do green. We'll switch it up. This law states for all real numbers x and y, x times y equals y times x. So let's say x is 4, y is 5. 4 times 5 equals 20. And 5. No, I don't have to rewrite that. And 5 times 4 also equals 20. Can we not? Thank you. This, of course, checks out. I'll rewrite that first part. I hate technology. This checks out. 20 equals 20. This works. Distributive law for all real numbers, x, y, and z and x. Y plus z, wait, what? X, y, and z. I'm checking out. For all real numbers, x, y, and z. X times y plus z equals x times y plus x times z. So this is just distribution. So say we take that. Can we quit? Thank you. This first part, this first equation, x times y plus z. We're just going. This is getting on my nerves. Miss Morris. Why are you making me do this? This is easy stuff. X times y plus z. Okay? Oh, okay? We distribute this x, into the parentheses. So this is going to end up as, can this write, please? Why is it trying to highlight? X, y plus x, z. Okay? Now let's take this second half. X times y plus x times z says what this should be equal to. Well, x times y is just, no funny business, computer. X times y is just xy plus x times z, which is, of course, just going to be xz. These are equal to each other, so this is true, so it all checks out. Zero factor property for all real numbers, x and y. X times y equals 0 if and only if x equals 0, or y equals 0, or both of x and y are equal to 0. So let's say, first example, x is 1, y is 0. Why did I write y? 0. 1 times 0 is 0. That works. If we switch it, x is 0, y is 1. 0 times 1 is still 0. And let's say they're both 0. 0 times 0, hello, is indeed 0. There we go. See, it all works. And, we can also prove when it doesn't work. If x is 1 and y is 2, 1 times 2 is 2, and 2 does not equal 0, So, there's that, I guess. Now we're going to be talking about, all this number stuff. You will have learned of this, in elementary school. You might have forgot, the actual names, but it's all really straightforward. So, real numbers. Real numbers include all rational and irrational numbers. They can be added, subtracted, multiplied, divided, except by 0. You can't divide by 0. And blah, blah, blah. So, elementary arithmetic rules and methods can be applied to them. So, 1 is a real number. I can multiply by 1, divide by 1, add 1, subtract 1. 1 plus 2, another real number, is 3, which is another real number. 3 times 2 equals 6. 6, another real number, They're cool like that. Real numbers, all of this, Cool. Rational numbers. Rational numbers are numbers that can be expressed as the quotient of two integers as long as the denominator is not 0. So, this is usually modeled by p... Hello. Oh, my pencil stopped working. P over Q, okay? And as P is going to be a integer, so it could just be, say, 2. And Q is going to be a non-zero integer, so let's say 4. Q can't be 0 because you can't divide by 0, you get undefined. Say, you have 100 sprinkles, and you need to put them on 0 cupcakes. How many sprinkles go on each cupcake? Well, I don't know, we don't have any cupcakes, so it's weird like that. And so, of course, this rational number is going to be 1 over 2, because it is modeled by P over Q. Integers. Integers are a set of numbers that include whole numbers, negative numbers, and 0. They do not include fractions, decimals, or ratios. So a lot of time, learning this in elementary school, they would say, visualize a number line. You have 0, you have 1, you have 1, you have 2. This is 0, of course. These are your positive integers. And then say we have negative 1. Oh my God. After I spent all that time writing a beautiful number line for you guys, I'll just continue. Negative 1. I'll ignore it, trying to highlight. Negative 2. So essentially, it can't be anywhere in between these numbers. It can't be negative 1.5. It can't be negative 1/2. It can't be negative 3 over 4. It can just be 0, 1, 2, 3, 4, 5. Negative, blah, blah, blah. You understand? I sure hope. Whole numbers. Whole numbers are a set of numbers that include all natural numbers and 0. They do not include negative numbers, fractions, or decimals. So take that exact same number line. Take that exact same number line. You don't you dare. You start at 0 and you just keep going. It's 1, 2, 3. Tell me it's not the first one. I'm not trying to type. 3, blah blah blah, and just so on and so forth, just forever. Okay, but it does not go negative. It doesn't go past 0. My beautiful drawing. It is not a fraction. 1/2 is not a whole number. It's not even whole. It's only half. We're talking about whole numbers, not half numbers. Again, not decimals. So, Morris, I should be getting paid for this. Natural numbers. Natural numbers. Natural numbers are a set of positive integers starting from 1 and extending
infinitely.
They do not include 0, negative numbers, decimals, or fractions. So it is literally just what we learned previously, but without 0. Whole numbers, but without 0. So now this time, your number line will be starting from 1. There's no 0. My number number line. And there are no negatives, okay? Decimals, fractions, blah, blah, blah. So your natural numbers are just going to be, where's my pen? You know, 1, 2, 3, and just goes on forever, you know? Irrational numbers are real numbers that cannot be expressed as a ratio of two integers. They cannot be expressed in the form of p over q. We learned this earlier that p, hello, do not do, no, we're not. P over q, okay? So, no. P over q. We learned that p is an integer and that q is a non-zero integer. So, as you already saw from the next slide, which got spoiled, you know, root 2 is an example of an irrational number. You cannot, I would say you can't make root 2 like a ratio. I guess you say root 2 over 1. Yeah, whatever. So this is, you probably saw this. Oh, okay, I'm stupid. Negative root 2. Hold up. Whatever. So you saw this, probably a line in elementary school, and you're learning about all of this, like blah, blah. And it's actually really nice. So all of these that we learned are real numbers. It's you know, like, natural numbers are real numbers, but not all real numbers are natural numbers. It's like how, like, I don't know, all Catholics are Christian, but not all Christians are Catholic, or all squares are rectangles, but not all rectangles are squares. I don't even know where I'm coming up with these analogies. Comparisons. I don't know, but this is really nice if you always forget on how they work. And yeah. Now we talk about inequalities between real numbers. Again, this is also going to be straightforward. So for any two real numbers, x and y, only one and only one of the following is true. It's either x is less than y, x equals y, or x is greater than y. You can't have x, you know, be equal to y and x be greater than y. Wait, what am I saying? X can't be less than y and greater than y at the same time. Now, of course, you can have, like, less than or greater to.
Putting this stupid video together, and I realized I said less than or greater to. It is less than or equal to. I'm just dumb.
But we're not going to talk about that. You can't have, whatever. For any three real numbers, x, y, z, if x is less than y is less than z, then x is less than z. So if x is less than 2, please work, 2, and then 2 is less than 3, then of course 1 is less than 3. This checks out. 1 is not greater than 3. I have one energy drink, and Miss Morris has 3 energy drinks. Miss Morris has more energy drinks than me. For any three real numbers, x, y, z, if x is less than y, then x plus z is less than y plus z. So again, if x is 1 and z is 3, you know, that's going to be, please don't mess with me. And y is 2 plus 3, you know, 1 plus 3 is 4, 2 plus 3 is 6, obviously 4 is less than 6. I don't think I need another example about energy drinks, because we all know that 4 is less than 6. For any three real numbers, x, y, z, if x is less than y and z is greater than 0, then z of x is less than z of y. Ooh, there was another problem. Whatever, okay, I'll do this example first. That's not 15, that's 5. So if 1 is less than 2, see x and y, and z is greater than 0, so let's say z is 3 again, then z of 1, so that is 3 times 1, is going to be less than 3 times 2. And so that's going to be, of course, 3 and 6. 3 is less than 6. We all know that. Erase. Again, 5, I just didn't check this. For any three real numbers, x, y, z, if x is less than y and z is greater than 0.
That does not say z is greater than 0. That says z is less than 0. I'm just stupid. This is just the part of the video where I start crashing out when I give up.
This is literally just the same thing, but opposite. You know, if I had, this was 1, 3 times 1, that'd be 3. If this was 3 times 2, that'd be 6. That 3. What was I saying? If x is less than y and z is less than 0. So if z is negative 1. I don't even care anymore. I hate this. Can I go to the next slide, please? That is it. I put a picture of my dog because she is cute and more fun than this. And I'm raging because this is annoying. Boop. Oh my god. Goodbye.